Good evening to all of you all. My name is Ramesh Srinivasan. I am a physics trainer for JEE and NEET. Today we are going to see a simple pulley block system. Consider a pulley fixed to the ceiling and two masses M1 and M2. Now, what are the assumptions? The assumptions are: number one, for the string, it is inextensible. The string is inextensible. And there is another assumption about the string, that it is massless or has negligible mass. And two, the pulley is smooth and it is massless. These are the assumptions. Let us see mathematically how these assumptions uh, get affected, how these assumptions affect us mathematically. First thing is, if the string is inextensible, well, if this mass moves by a distance x, this will move by a distance x. So the displacement is the same, the velocity is the same, the acceleration is the same. That is, the masses and the string will have the same acceleration. That is the assumption. Then another thing is, if the tension, the strings are T1 and T2, if the tension here is T1 and the tension here is T2, for the string, if you lay it straight and put it, it is T2 and T1. Now, T2 minus T1 is mass of the string into the acceleration by Newton's second law. Now, if the mass of the string is negligible, T2 minus T1 becomes 0, and so T1 becomes equals to T2. So, if the string is inextensible, the acceleration is the same. Acceleration is same. The acceleration is same. And if it is massless, T1 equal to T2, the tension is the same on either side. That is how these assumptions manifest. Now, if the pulley is smooth, then what happens? If the pulley is smooth, then it will not rotate. The string will simply slip over the pulley. So, pulley does not rotate. Where is the thing? Okay? And if it is rough, then it will rotate, and if it has got mass, then there will be some energy which the pulley also takes up because of rotational energy. So these are the assumptions. So if these are the assumptions, then the question is, how do we write the equations? Let us say the acceleration A is downward here, A is upward here. Then we can write for this m2g minus t2 is equal to m2 into a. This is the equation, because the net force has to be downward, because the acceleration is downward, the net force is downward. m2g minus t2 is equal to m2a, and for the other mark, t1 minus m1g is equal to m1a. And we also saw T1 equal to T2. So therefore, there are three equations and three unknowns. So we can easily solve for them. Okay. Now let us say the pulley is not smooth, but it is rough. It will rotate. What rotates it? It is the force of friction. Let us see. That is the collision, and we have the string going around it. I have shown the string separately. This is T2, this is T1. Now, see, the string is moving, has a tendency to move in the clockwise direction because we are assuming M2 is greater than M1. So, if it is moving in the clockwise direction, it slips in the clockwise direction. So, the frictional force on the string will be in the anti-clockwise direction. And by Newton's third law, the frictional force on the pulley will be in the clockwise direction. Okay, so it is this frictional force which rotates the pulley. So now the pulley is rotating. There are two cases that can really arise. What are the two cases? The pulley does not slip or it slips. If it does not slip, yes, the string and the pulley move together. There is no slipping. If there is slipping, the string moves ahead of the pulley. So first let us take the case where it does not slip. Where it does not slip, now if you write if the angular acceleration of the pulley is alpha, then the tangential acceleration will be alpha r, where r is the radius of the pulley. Now this alpha r will be equal to the acceleration of the string because they are not slipping. So how do you write the equation now? Well, it is the frictional force which is causing the torque. So F into R will be equal to I, the momentum inertia of the pulley, into alpha, and alpha I into alpha. This is the torque equation. Force into the distance R is I alpha. Now the string, we can write T2 minus T1 minus F. T2 minus T1 minus F and T1 are in the same direction, as you can see. That is equal to the mass of the pulley, mass of the string into the acceleration A. But mass of the string is negligible. Therefore, F will be equal to T2 minus T1. F will be equal to T2 minus T1. So now how do the equations look? The equations will be, for the masses, it will be M2G minus T2 is equal to M2A, and T1 minus M1G is equal to M1A. So how many unknowns are there? So let us see the equations 1, 2, 3, 4 and 5. There are 5 equations, and how many unknowns are there? 5 unknowns. T1, T2, A, alpha and F. So 5 equations, 5 unknowns. Okay. Now, if there is slipping, then what happens? If there is slipping, F will be equal to the limiting value of the force, limiting value of the frictional force, because there is slipping. So now you cannot say if F is equal to F limiting and there is slipping, we cannot say alpha r equal to A. So this one equation is out. Alpha r equal to A is out. So we now need a fifth equation. That fifth equation can be found out as T2 is equal to T1 into e power pi mu. We can relate the two tensions on either side to the coefficient of friction. T2 minus T1 is equal to e pi. The derivation of this is quite simple. I shall do it if time permits. So T2 minus T1 is equal to e pi mu. So now we have the fifth equation here. With these five equations, we can solve for all the unknowns. Thank you.